Swati Nanda, welcoming all students of BA Political Science Honours 6th semester to this class of Research Methods in Social Sciences. In today's class, we would begin our discussions on qualitative and quantitative data analysis, and today we would focus on quantitative data analysis. As we already know, qualitative data analysis is based on classification of objects according to the properties and attributes, whereas quantitative analysis is based on classification of data based on numbers or computable values. Qualitative analysis is subjective, whereas quantitative analysis is objective. Today we will focus on quantitative techniques. Quantitative techniques can be used to understand the relationship between the various elements of the data. For this, one needs to break the data into various parts and look into the ways in which they relate to each other. This helps us to make predictions based on the data. There can be two types of quantitative analysis. One is descriptive, which is the most usual common kind of analysis that we make. Second is inferential. Today I will try to give you some hint about the kind of analysis that we do in descriptive and inferential analysis. Descriptive analysis provides information on the basic qualities of data and includes descriptive statistics such as range, minimum, maximum, and frequency. It also includes measures of central tendency such as mean, median, mode, standard deviation. There are different ways to describe data, and descriptive analysis can describe the data, what the data looks like. Suppose we have chocolates of different prices in front of us. We have 4 chocolates that are priced at 5 rupees, 2 10 rupees chocolates. We have 3 chocolates costing 20 rupees each. So it will be, the data set will be like 5, 5, 5, 5, 10, 10, 20, 20, 20. In this case, the range, which refers to the difference between the highest and the lowest score, would be 20 minus 5. So the range would be 15. The minimum in this case, which is the lowest or the smallest score in any data set, here it would be 5. The maximum, which is the highest or the largest score in a data set, would be 20. And the frequency, the number of times a certain value appears in a data set, in this case 20 appears 3 times, which can be expressed as a percentage. The score 20 appears how many times? If we try to convert it into percentage, 33% of the time. Measures of central tendency. The measures of central tendency can give us an understanding of how participants are responding in general. These measures include mean, median, and mode. Mean is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data. The average or the sum of values divided by the number of values is the mean. When we need an average of the data set, we use mean. The problem with mean is that it cannot take extreme highs or extreme low numbers. It gives equal value to all numbers. In the above case that we discussed, where we have 4 chocolates of 5 rupees each, 10 chocolates of 2 rupees each, and 3 chocolates of 20 rupees each. We have 4 chocolates of 5 rupees each. We have 2 chocolates of 10 rupees each, and we have 3 chocolates, each costing 20 rupees. In this case, the mean would be 5 plus 5 plus 5 plus 5 plus 10 plus 10 plus 20 plus 20 plus 20. And we can divide the entire sum that comes out of this addition, divide by 9, since there are 9 numbers. So the result would be 11.1. So that would be the mean here. The median. Median is the middle mark of the data. When the data set are arranged in a numerical order. To find the middle position, first we have to order the scores, count the number of scores, then add 1 and divide it by 2. In the above case, the median would be 10. Median is less affected by the highs and lows of numerical groups. Let's come to mode. Mode is the most frequently occurring score in any data set. It is used when we want to know which is the most common category in the data set. Problem arises when we have 2 or more values that share the highest frequency. Another problem with the mode is that it will not provide us with very good measure of central tendency when the most common mark is far away from the rest of the data in the data set. In the above data set that we just discussed about the chocolates, we have 4 chocolates of 5 rupees each, 2 chocolates of 10 rupees each and 3 chocolates of 20 rupees each. The mode would be 5. Let's come to standard deviation. When we think about how the respondents of a certain survey or experiments are responding in general, we take the mean, the median or the mode. But we also need to consider how far apart or close together the participants' responses are. To understand more about the nature of the data, we can consider the standard deviation. As a measure of how close the scores are centered around the mean score, standard deviation shows how well the mean represents all of the data. A standard deviation represents the average amount that a given score deviates from the mean score. Now let's go over to inferential analysis. Once the data have been properly described, inferences can be made based on the data set. Inferential analysis uses statistical tests to see whether an observed pattern is due to chance or due to program or some kind of intervention effects. Research often uses inferential analysis to determine if there is a relationship between an intervention and an outcome as well as the strength of that relationship. One of the first steps in inferential analysis is to answer the question, what does the distribution of data look like? Distributions fall into 2 categories, normal and non-normal. Normal distribution looks like what is called the bell curve. The bell curve. The graph that you see on the monitor on your screen is an example of what a normal distribution looks like. This type of distribution shows that the majority of the data is clustered around one number or value. Usually, if the data is normal, statistical tests called parametric tests are used. There are various means a distribution can be non-normal also. It could be non-normal because of small sample size, because of unusual states of responses. Usually, if the data is non-normal, statistical tests called non-parametric tests are used. This type of distribution does not take the shape of what we just discussed, the bell curve, and it can be skewed positively or negatively. It is called positively skewed if the majority of the scores are at the lower end of the possible scores. But if the majority of the scores are at the higher end of the possible scores, then these are called supposed to be negatively skewed data. Let me also introduce you to another concept. It's called Cortices. Cortices describes a distribution that is either too sharp or too flat. Cortices is a statistical measure that is used to describe the degree to which the scores cluster in the tails or peak of a frequency distribution. The peak is the tallest part of the distribution and the tails are the ends of the distribution. There are three kinds of cortices: mesocortic, leptocortic, platycortic. Look at this diagram on your screen. It's been taken from the internet, ResearchGate. Mesocortic, leptocortic and platycortic. Mesocortic distributions are moderate in breadth and have curves which have a medium peaked height. The first one is mesocortic. Leptocortic. In leptocortic distributions, more values in the distribution tails and more value close to the mean. These are sharply peaked with heavy tails. Second one is leptocortic. Third is platycortic. In platycortic distributions, fewer values are found in the tails and fewer values close to the mean. The curve usually has a flat, very flat peak and has more dispersed scores with lighter tails. The third one is a platycortic distribution. So let me end here today. We will go over to qualitative data analysis tomorrow, again in a very short lecture. When the college reopens, we can discuss all this in detail. Till then, I wish all the best to you in all your efforts to studies, and I wish you best of health. Please take care of yourself, take care of your family members, especially your parents, your grandparents, and your any family member who is a kid. Thank you.